it has the shared pair and
No, start with the size. What happens across the period to the size?
it increases.
Size.
Oh wait, it decreases.
So as the size decreases, the bond pairs, they come closer to the nucleus or away from the nucleus? Talk like this.
Science. But doesn't across the period the size stays the same?
No, dear, it decreases. Because across the period, you're adding protons inside the nucleus, but number of shells and the screening effect is same. So the nucleus is more positive. So it's pulling the electron density more closer. Size decreases across the period, Aditi. Okay?
So
Okay,
since size decreases, the
okay, you frame your language, okay? I give you a few seconds. Think and frame your language. Avni, can you answer why this electronegativity increases across the period?
I can't hear you.
Oh, you can't? Now can you hear?
No.
You're breaking away.
Okay, now is it better?
Yeah, yes.
Okay, sorry, I just have to change this. Yeah. So basically, across the period, the size basically it decreases because you're adding protons. So the shielding effect and number of shells also stays the same. And when you're adding protons, so basically when you're and
Okay, your voice is
so
also
Breaking away.
your voice is breaking away. So let's go back to Aditi. Aditi, are you ready?
yeah.
Okay, I
Yes,
give you
because
hints. Electronegativity increases across the period because size decreases. You start from here. So what happens as the size decreases?
protons and neutrons are being added.
No. I'm not asking reason for size. I'm asking what happens to
Oh.
electronegativity if the size decreases.
Then electronegativity increases.
Now explain that part.
Because the shared
This one
of electrons
is
is
more closer.
More closer to the nucleus.
Yes. And if it is more closer to the nucleus, so it means
if it's more close to the nucleus, attraction increases.
So the electron density will go more in the direction of smaller one.
The smaller
can you hear me now? Is it better now or?
Yeah, it is better. Yeah.
Negativity will go B and electron positive. Wait, yeah, partial positive would go.
Okay, another question. There is an fluorine bonded to chlorine. Who will have partial negative and who will have partial positive?
Fluorine and partial.
Fluorine will have partial negative and chlorine will have
Partial
partial
negative is
positive.
fluorine and partial positive is chlorine.
Very good.
Yes.
Very good. Because down the group, what happens to electronegativity? It
decreases.
It decreases.
Because size increases.
Because size increases.
Yeah.
Perfect. Very good. Today, Kyra is using very good language. Proper chemistry teacher language. Very good. Okay, so are we ready for the next topic? Ionization energy, right? So for the ionization energy, first we need to understand the word and then we are going to understand the concept. Okay. So 1 second. You have that booklet with you?
You mean the chemistry one? I haven't printed it out
Wait,
yet.
what do you mean the booklet?
I'm just going off of it online. I'm like taking notes out by reading it online.
Okay.
Which
Yeah, I have the printout of the last year one, but I didn't take the printout of this year.
Yeah,
are you
That's
I
talking
okay.
use
about?
There's
online
Are you
version
hardly,
because
talking?
like there's
there is
so
no
like
change. There is no much change. So there is no need of wasting so much pages. If you have already the printout, that's fine. If you can learn online, that's also good.
Okay, should I get the booklet or?
No, there is no need. Okay, now
Okay.
Aditi, this is the book I'm talking about.
Yeah, I've seen that book.
You have seen that? Okay.
Yeah.
So we are following this book. So I'm going to teach you more in depth from this book only. So right now we are doing section 2 we have already done, right? Measurement. We have finished with that.
yeah, we did.
But if few things are left, I'm going to touch all of them again.
I think we also didn't do the first one, or maybe
What
yeah,
are
I
We
the
don't
were
think we did the
looking
first one.
at we
Okay, we'll
were
see. Yeah, we'll see later on. Right now we are working with periodicity.
yeah, periodicity.
Periodic
I think
table.
it's like the 6th or 7th section, I think.
Classification is third. Yeah.
Wait, it was. We also looked at
Yeah, here.
oh yeah.
So I want you to read from this book also. That's why I'm showing you. Come in the habit of reading books. You start reading from here, periodic trends. This is what we are doing. Okay, so we discussed the electronegativity, right? You read it from here, you will get the good language. See, the language is written here. They are talking about electrons, protons. There will be slight difference, the way they are explaining, the way I'm explaining, but this explanation will going to be the same. Okay, so now this question, this is the example. Okay, now one thing is missed. Where are the noble gases? You know where are the noble gases?
Yeah,
Yeah,
Far
they're in
right
the
they're in the
side.
group on the
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 last
exact
last
right
group.
group.
side.
They're the 18th group.
So do you think noble gases have any tendency to pull electron? Do you think noble gases can make bonds?
No.
So we never talk about their electronegativity,
Yeah.
okay? Because noble gases are inert.
But then why
They,
did they do some? Why did they like color in some?
pardon?
So above it's saying like the scale, and they colored it in to show which ones like of electronegativity. So
Yeah.
they color in some of them.
Yeah,
They don't
yeah.
ever
Yeah.
talk.
Why do you need a color?
Because for these gray one, we don't talk about it, right?
There's some that can
They
have
cannot,
electron.
yeah. But
Like
these
krypton and
two,
neon
krypton and xenon.
or xenon?
So they are talking about krypton and xenon because they are the one which are polarizable. So maybe that's why they have shown it. But krypton and xenon can make chemical bonds. They are making chemical bonds with oxygen and fluorine. Very rare examples. So let's see what they are writing about noble gases. See here. Neon is a noble gas, is not listed. So because it has already a full octet. What is the outermost shell of neon? You remember? Is
I
he?
think
It was
M.
the outermost shell.
Oh,
MS.
you mean
Um,
that configuration?
Yeah.
2s2 and 2p6.
So
two.
outermost
Yeah.
shell is 8, right? It's already with 8. So they say that neon doesn't want to gain or lose electrons, so it's excluded from the list. But you're right, xenon and krypton they have added, but I'm really surprised that why they have made it highly electronegative. You see, they have made it very electronegative like this.
Yeah.
But they are not so electronegative and they make only compounds with fluorine or with oxygen. Krypton also with fluorine or with oxygen. Like you can see these compounds because they are quite big in size. So XeO3,
I have a question.
XeF4, yeah, KRF.
What does Pauling scale mean?
Yeah, Pauling scale is the values
Does
assigned
it
of
mean like
electronegativity.
is it like kind of like a unit or something for electronegativity? Like it like says which one is more greater in electronegativity and which one is more less in
So
electronegativity?
Shall I show you the Pauling scale? I'm showing you the Pauling scale, children, here. Just give me 1 second. I'm pulling out the Pauling scale. Sharing it with you. Can you see this periodic table?
Yeah, it looks different.
These are the electronegative values assigned to the elements. These electronegative values were
Is it like 4.0
given
to
by Pauling.
0.7?
This was given by Pauling.
Oh, it's another
Pauling is
like it's another thing
scientist.
that's named after a scientist.
Yeah. And it's a
Another
scale.
element.
It's a scale, just like you have logarithm scale, this scale, that scale. So it is also a scale. He did some mathematics. He made some formula and he assigned electronegative values to all the elements of the periodic table. Now, which
How
one
come
has the
there's some
highest value?
missing?
Yeah, noble
There's like
gases are not there. I don't know why they are mentioning it.
no, but there's also like hydrogen that's also missing, and like
Hydrogen
the
is here.
oh
What about
but
helium?
like what about the entire like
Entire
length
noble
of the
gases are
atoms?
missing because we don't assign them electronegative values.
Wait,
What
but
about
And
the
this one is
hydrogen?
missing. This one is missing because they are radioactive. Remember, I was telling you that most of the time we'll talk about cesium and we'll not take noble gases and we'll not take the 7th period. 7th period are radioactive. So they are missing. Noble gases and
oh
7th.
yeah,
Now look at the value, Avni. Which one has the highest electronegative value?
Fluorine with
And
4.0.
and it's very, very small also. It's the smallest, right? And which one has the smallest or largest?
Cesium. Cesium
Yeah,
CS.
cesium.
If cesium is approaching fluorine, what kind of compound they are going to make? Ionic, covalent, or what?
Ionic.
Covalent.
No.
No,
Met-
it's ionic because it's not non-metal with non-metal.
Oh yeah, it's ionic.
oh ionic.
So you will get ionic compound when the difference in electronegativity is very high. Difference means delta, change. Big delta this time. When the difference of electronegativity is greater than or equal to 1.6, then is ionic compound. Ionic compound. Like oxygen with sodium. See the difference? More than 1.6? 3.5
Yeah,
minus 0.9. How much is this? 0.9. Isn't it 2.6?
2.6.
0.6.
2.6, which is more than 1.6. So that's
It's
the
more than
reason
1.6.
when metals are approaching non-metals, then the difference in electronegativity is so big that non-metal, Avni here, non-metal is going to gain the electron and metal is going to lose the electron. This is due to difference in electronegativity. So very soon we'll start talking in terms of this also. Is the Pauling scale clear?
Yeah,
Okay. Pauling scale, what is Pauling scale?
it shows electronegativity. It
The, these are
value
the
of
the
electronegativity.
values
It
for
shows which
like
ones
it
like have
high
greater.
values
Mhm.
and low
Which one has
values.
the highest in electronegativity and which one have the lowest.
Yeah,
And
these are the
they
values of
make ionic.
It helps you
electronegativity.
determine which ones have more
the
electronegativity and which ones don't.
it
For comparison, yeah. Now, look at the definition of electronegativity. Do you agree with the definition? Don't worry about this symbol. We are not using it. But do you agree with the definition? Electronegativity is a chemical bond, right?
Yeah.
So
Yeah.
it's a molecule. So it is a measure of ability of an atom in a molecule, means where they are bonded to each other to attract electrons to itself. And who was the scientist who worked on it?
Linus
Linus
Pauling.
Linus Pauling.
Or
Yeah, he died in 1994. Before I think you were born. All of you are 2000 kids, right?
Yeah.
Mhm.
Yeah,
Always.
2012.
I don't
Honestly,
think we'll
yeah.
be that old.
Like, yeah.
Mhm.
If we're
You are not
11 or
23
12
years
this
old.
time.
You must be around
Yeah.
10, 11, right?
Yeah, I'm
Yeah,
10.
I'm 11.
I'm 11.
Okay, okay. So periodic trends, electronegativity, that's already we have done. Now ready for the next trend, the ionization energy. I'm giving you definition of ionization energy here.
Question.
Yes.
Oh, on the slide before, what was the X?
That
Like the
symbol,
slide you.
that was the electronegativity symbol. We are not using.
Oh,
Don't
okay.
worry. Don't worry. We are not. That's not X. That's Xi.
There's
Greek. Yeah, Greek letter is like this.
Did
But
we
why
write
do they
this
use these
down?
Greek letters?
Science started from there. From
Like,
they were the most scientific people earlier. So that
they like used a lot
started
of
using.
Greek
But
letters.
why did it never like ever change?
No, it
Because
can be
like
changed.
Like, it can be
Like
changed.
like I said,
it
we are not
can be
using.
changed, but why didn't it be changed? Because like then you could kind of understand it more easily.
Okay, I tell you the reason, Kyra.
I
Kyra,
learned
when
Greek.
you become a scientist, right? What is a scientist? Scientist is always starting doing innovative things, trying to work out something new, something new. So when you are working on something new, then scientists are always referring very old books, very old concepts. So they are using these Greek books and all scientists what they were saying about this. So they are referring materials, and there they are using Greek symbols. So the new scientist he is also now comfortable with Greek symbols. Science is not something which you can just sit and make a new thing. You're always dependent on the previous information. So they are researching the papers, old books, what that scientist said in that year. If you're watching any science serial like Big Bang Theory, so many serials are there. There you'll see that they're always talking about research. They're doing research on papers, research on books, and they are all books. They have Greek letters. Is it okay? Glucose
Yeah.
is a very old name, and we are not changing it. We are still using it. Very old. O's. O's means sugars. Fructose.
Well, fructose.
It's also O's. It's also sugar. Sucrose. It's also O's. It's also sugar. Sucrose is table sugar, the one which you eat. Table sugar, right? That is sucrose. Okay, read the definition of ionization energy. You're going to take an isolated gaseous atom. Isolated gaseous atom like sodium. But it should be in the gaseous form, not in solid form. It should be in the gaseous form. And then you are removing one electron from its outermost shell. So when you remove electron, you get Na plus gas plus one electron, right? Aditi, may I request you to mute your mic?
Oh, sorry.
This one, right? It's okay. Let them talk. Okay, Aditi, when you have to answer, just unmute. So now what is happening? You already know that sodium is nucleus, shell number 1, shell number 2, and shell number 3. In shell number 3, there is only one electron. In shell number 2, there are 8 electrons, right? 8. 1, 2, 3, 4, 5, 6, 7, 8. And in shell number 2, 1, 2 electrons. 1, 2. So now we want to remove this electron, outermost electron. So when you remove the electron, then it becomes positively charged. Agreed? It's a cation after removal of electron. But is this removal of electron is the breaking of attraction or making of attraction?
Breaking.
Breaking of a trap.
The breaking of attraction.
Breaking.
Attraction of the electron with the nucleus, you want to overcome them. So what is needed? More
Yeah.
energy or less energy?
More energy.
Energy.
More energy is
More.
needed. Means energy is needed. If energy is needed, oh sorry, I think I asked the wrong question. So what is happening here? We need energy, right? To remove this electron.
Yes.
So this process is endothermic, exothermic.
Could you
Energy
repeat
is
the
needed.
question?
Energy is needed, right? Required.
Exothermic?
No endo.
Wait, could you repeat
Wait, no, wait.
Endothermic?
the
Or
question?
endothermic?
Endothermic.
Ex-
I was asking Aditi, the process is endothermic or exothermic?
Endothermic.
Endothermic, why? Because energy is
Because
needed.
energy is added.
Yeah,
Energy is
endo
needed.
means, Kyra, endo means
Endo means
in. Exo means
means out. I thought you were saying
Out.
like to remove, because that's what I heard like a couple sentences before. So I thought you were saying to like remove something. So that's why I thought it was exothermic.
thermic means heat.
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 Heat or energy.
Then you said that you are
Energy.
breaking attractions. So
So
whenever
that
you are
means
endothermic, heat is needed, right? Heat is added, heat is needed. Okay, now let's see the periodic trend, which is very easy to understand. Atomic size down the group increases. Atomic
Yes.
size across the period decreases. So
Yeah.
as I go down the group, what happens to the force of attraction between the nucleus and the outermost electron?
it increases.
It
Decreases.
decreases
No, it
because of the
decreases. It
distance.
decreases because it's
It
bigger.
because
the
of the
distance
distance of
between
separation of charges,
Because the
and
distance of
it's bigger.
separation is
So that
more
means
decreases
because
if
of
it's
the
more
when the
shells,
shells are
size
the
piling up.
distance
So
of the
when the size goes bigger, then it'll decrease because the distance of separation of charges. Because if it goes more farther away, that
Less
means
attraction.
force of attraction is less.
Okay, now Kyra,
It
your
adds
turn
more
is over.
shells.
Now Aditi and Avni, let's see who is going to answer. Kyra, you are going to listen carefully this time. Okay, so in which case, Kyra has already answered it. Now you have to give the language. In which case, it is more easy to remove the electron, the big one or the smaller one?
the big one.
Smaller one.
Okay, the big one Avni is saying, smaller one Aditi is saying. Okay, Avni, can you give the reason why?
Yeah, because basically, if it's bigger, it means there's more shells and more shielding effect. So basically, it's not. So it's more shielding effect, and also because if it's bigger, then the nucleus and the electron are farther away. So basically, the force of attraction is less, so it's easier to remove it.
Aditi, do you want to do some correction in your answer now?
Yeah.
Okay, with
I
a
think
smile.
so.
Okay, good. So, big one has low ionization energy. Can I say that?
Yeah.
Big atoms, in big atoms, attraction of electron with the nucleus is less. Attraction of electron with nucleus is less. Due to more distance. I want you to read that book and underline the sentences, the words which you want to discuss with me in the class. So when you are reading the book, you have to understand each and every word. Okay? Due to more distance between
The nucleus and the
and the
electron.
electron. Yeah.
I have a question.
Mm-hmm.
So it's about like the books. Should we be reading both of them or should we be reading the newer version?
Newer
Because
version.
it's like a study material. Okay.
Yeah, you can read online. Online, if you have tab, you can sit in your bed and in the night, just read one paragraph, underline the words, or write down in your notebook. This word is not clear, like this. Ask it in the class. So next time your homework is, the one homework is compulsory, children. Every
Okay.
time we'll start with the questions from U3. You're going to bring minimum 2 words from the book. That these 2
Mhm.
words are not clear. Okay? Avni, is it clear? So read the book and bring minimum two words. Minimum is 2, maximum can be, but only from the things which we are doing. Don't try to bring things from the topics which we have not done.
Mhm.
Speaking of homework, I had a question from the quiz, like after this because
Yeah. Okay. Let me check your quiz first. I'll answer it there only.
okay.
Okay. If
Okay.
still not clear, then we are going to discuss it. So read about atomic radius. So maybe you'll find few things I have not covered. I'll cover that also. Electron configurations are done. Read about these electron configurations. So where is the ionization energy?
You passed it. It was more down.
Yeah,
Yeah,
this is
more
Yeah,
down.
it was more
Yeah, here.
down.
Yeah, here.
Yeah,
It's right
right
there,
here. Yeah.
yeah, you just had it. Yeah.
So I think we are done. What about ionization energy of the? There is some error in this book. So just ignore them. They have shown of the noble gases, right?
Wait, but the noble gases don't.
No, they do, but they have the highest.
Oh.
They have
Oh,
the
this is
It's
high.
kind of
I forgot.
decreasing. But then why is it kind of like
Then
decreasing?
maybe like
Because
the
you
white
said it
is
has
like
the
the
highest.
lowest. Maybe
Because down
white
the
is highest,
periodic
and then
table
the
it decreases.
down the group decreases. So
Yeah,
when
because
you
down the group it will decrease. But you said it was like the highest. So wouldn't it be like more like 2 of them are like one level and then the next 2 are like
no,
another
they have
level
the
because
highest. Can you
they're the
explain
so
highest.
why
maybe
they can?
the lighter it is, maybe it's higher, and maybe the
I know why it's
darker it is, the lower.
decreasing, but if it's the highest, then shouldn't it be like a bit more higher?
Red, yeah. The one which they are not highlighted here, generally we are not talking about them. Is it the 7th period?
Yeah, it's a 7.
Yeah.
We don't talk about F block, we don't talk about 7th period, and we generally don't talk about noble gases. But here we are going to talk about noble gases because noble gases have the most stable configuration, fully filled. So it will be very difficult to remove electron from the noble gases. Is it okay?
Yeah.
It's very difficult to remove electron from noble gases. Yes, Avni.
I don't have a question.
Okay, good. So the periodic trends are over. So this is your homework. You are going to read it. Let's see if something we have not covered. Yeah, these metals we have not covered. So shall I start with these elements? So I'm starting with the
Yeah.
elements
Okay.
from the starting only.
Okay.
Yeah, section 5, periodic table and periodic trends, right? So you already know the meaning of chemical symbols. If I write on chemical
Yeah.
symbol like this, X,
That means the
what is X means? Symbol?
X means
The
the
symbol,
X
symbol.
means like
element symbol.
the
X means
the
the
oh
symbol.
the symbol. A
And the
means
Z?
the Z
I think
means
that means
Atomic number.
atomic mass.
mass.
Atomic
Number.
number.
Wait,
The
no,
number.
atomic mass is
Number,
A.
yeah, number.
That's
Atomic
the
mass
number,
is
and
A.
then the
That's
top.
the number.
Atomic mass is there.
Yeah, but in the periodic table, with the periodic table which we are using, the things are not written like this. Okay, let me show you the periodic table. You can see this one.
Yeah.
Yeah.
See, atomic number is written on the top and mass number is written at the bottom. And which one is more always? The atomic number or mass number?
The mass number.
The mass.
Mass.
Do you know any element which has the same atomic number and same mass number?
Hydrogen? I
Yeah.
mean,
Yeah.
yeah, hydrogen.
Yeah,
Like, doesn't
hydrogen.
hydrogen not
hydrogen.
exactly have one? Because isn't it like 1.01 or something like that?
I'm talking about hydrogen atom. 1.01 is the average atomic mass. That I have to discuss with you. Okay. That we have not done yet. So we are going to discuss that.
I think
Okay.
you did discuss it. I think you said that hydrogen was called a
Yeah.
proton because
Three
it's the
isotopes.
average mass of the
I think
isotope.
average.
yeah.
But like,
We'll go
isn't that
more
kind
in
of the one
detail.
that we're using? Like, we always use the atomic mass, like the average of it. So if we're
Average
using
of
the
all the
average, then wouldn't it
isotopes.
not be exactly the same? Because there's still a slight difference.
But I'm talking about one of the hydrogen atom, one of the isotope, H11,
Okay.
not H11. This one.
Isn't this section about mentally? How do you pronounce this scientist's name again?
Oh,
Me-
where? This
the
Jacob
Mendeleev?
Berzelius?
Oh no,
Mendeleev.
not him. Yeah.
Mendeleev's periodic
Mendeleev?
table. Yeah.
Oh, okay.
There's an element named after him.
Mendeleev's, yeah.
Which element?
Yeah, it's
Mendelevium. Right?
Oh,
Mendeleev.
101.
Yeah.
This is
101.
an Einstein one.
And there's
Einsteinium.
Einstein.
There is one on the
Einstein.
Rutherford also.
There's also Lawrencium and
There's
yeah, that's
Nebelium.
the only one I know.
And there is one on Bohr also.
Bemarium. Wait,
So-
what? There's one
So
on boron.
when we learn the scientists, we'll look at the symbol also at that time. Okay, right now you don't know Rutherford, you don't know Bohr's, so leave it. So Mendeleev's
Isn't Bohr's the one that made
atomic
the
structure.
electron?
No,
He made the electrons.
no. Bohr's he
Oh.
discovered that inside the atom there are shells.
Oh, okay.
The first electron configuration you were doing K element.
Yeah,
Remember
Oh, yeah, I
initially
remember.
that was given by Bohr.
Yeah,
that was long ago.
Long
that was,
ago. But
that was like a
still,
month ago or 2 months
Like a
ago.
month ago
Wait.
or something like that.
Wait, I have a
Yeah,
question.
something like that.
I have a question. Is the Lewis dot structure is the guy that named it named
Louis.
Lewis, and also is the element named after him Lawrencium?
Lawrencium and Lewis, I don't think it's matching.
Oh, right.
Lewis is
Okay.
Lewis. But I don't know his full name. I just know the surname.
Maybe it's liver. No, wait, no, it can't be
How
that.
come they always use his surname as the as it? Like, why can't they use
I
like
feel
the
like
first?
Lewis should be the first name.
Yeah,
Oh, yeah,
Is it?
yeah.
it doesn't seem like a last name kind of thing. Just
If you are so much curious about your scientists, then you must see online. Like one of my student, I told you from your area only. So Louis, scientist. So what she was like when she was of your age, she was making their portraits. Whatever scientists I used to discuss in the next class, she used to show me. Look here, this is Louis. Here, she's still with me. She's learning organic chemistry. I'm asking her, okay, you're done. She's saying, no, I'm not done. See, I think this is Louis. This one. His name is Gilbert and Louis. You can see him.
Yeah.
So you can read about them.
but why isn't like it Gilbert dot structure?
Oh, no. Generally,
Because like
the
shouldn't it be the first name? Because like many people have the same last name. Because
but
for
many people
example,
have the
this
same first
person,
name. Many of
yeah,
them.
but
There are so many
Yeah,
that's
Aditi.
common.
because there are more
Because
Avnis
for
than
the
there is
last name
Bagamais.
okay, so this person's family has a lot has that exact same last name, but that doesn't mean everybody in the family has the same first name. Like
But I
it's
don't
more
think
common
everybody.
to have the same first name.
No, because
Yeah.
if somebody were to give them credit, then they would be like they wouldn't want to take credit because it's their own family member. So I feel like
No, actually, see, the surname is better than first name because first name anybody can claim. No, my name is Gilbert, or I can name my baby as Gilbert, right? But I cannot change the surname of my baby, right? So that's why. So let's give the credit to the family, the way Avni is saying. There are so many Avnis, so many Khairas. Aditi, I have 2 Aditis on my website only. There are so many Nehas. I have taken like nearly 5, 6
there's
Nehas.
a,
Nehas a lot, right? So that's
There's
why.
a common name.
For
there's
me,
lots
there's
of
more Avnis.
Arnavs. There's
Shall
a
we
lot of Avis.
Avnis are less, I think.
In my school, there's at least 5 Avnis.
Oh, nowadays maybe it's a popular name.
There's a lot of A names, like, or like,
Yeah. Okay, so shall we continue? Moving away from the names, now let's see who was Mendeleev's. So Mendeleev was the first person who tried to make the first periodic table. Periodic tables they started making very early. Like there was one octave law. Many scientists tried it. But
oh,
Mendeleev was the first one with maximum elements in his hands. By that time, many elements were discovered. And he made a first very good attempt of arranging the elements according to their chemical and physical properties. But there were many errors, many errors, because
yeah,
his
he did
periodic table was based on
atomic,
masses.
Atomic number,
so atomic
atomic
mass,
mass.
atomic
And
Yeah,
mass.
atomic
chemical
mass.
properties are governed by chemical
Atomic
properties.
Mass, atomic
number.
number.
Yeah, because
Number,
chemical
yeah.
properties are governed by electron configuration. And atomic number is equal to number of electrons. So
Yeah.
arranging the elements based on atomic masses was full of errors because atomic masses are not going to determine the chemical nature. Atomic number is going to determine the chemical nature. So that's the reason Moseley, the second scientist, he made the
Fixed it.
modern periodic table, Henry Moseley.
So I use now,
He used
like this now.
X-rays. When he was doing experiment, he was using X-rays to understand the chemical nature. And then he found that chemical nature, how the X-rays are interacting with every element, and he found that it is based on the electron configuration. And from there, he made a periodic table based on atomic number, and that is the best periodic table, and we are still using it. Right? So what's the definition of the periodic table? Let's write down the definition of periodic table.
Okay.
Elements are, okay, I'm writing it. Okay, don't wait, please. I'm writing, you see here,
Oh,
because I have to think before I speak something. Yes, chemical, because this is a definition, we have to be very accurate. Chemical and physical properties
that's what the periodic table is. Oh
are
yeah.
of elements. Of elements are periodic functions of their atomic number. Atomic number. Chemical and physical properties of elements are periodic functions of their atomic number.
Yeah.
We are okay with this?
Yeah.
Yeah.
It makes sense.
Okay, so Mendele's periodic table was a fail, but still we remember him, and one element is named after him because it was the first systematic organized periodic table. Then with full of errors because atomic masses are not the periodic function of the chemical and physical properties. So Moseley, nowadays we are using modern periodic table, which was given by Moseley. So you are okay with the groups and families? So
Yeah.
please read about groups and families. So elements of the same of a group of a family, they have the same chemical properties nearly, right? Why? Elements.
Wait.
Because they have
They have the same
a
physical
near atomic
properties.
number, and also because
because
they're in the same
They
group.
have they.
Mhm.
What's the question again? I was
They're wait. Yeah, I
Yeah,
couldn't really
in
understand.
groups or
What was the
periods. In groups or
question?
periods.
Okay, now both of you now listen to my question carefully. Elements in a family, in a group, they have similar physical and chemical properties. Explain why. Chemical properties are governed by.
because
Yeah, Avni.
Chemical
their
properties
atomic number
governed
is very
by.
similar.
they're governed
and
by
also
their
because
atomic number.
Their atomic.
and their atomic
They're
number
governed
is
by their
very similar.
No, Avni,
they're
you're
governed
wrong.
by their atomic number.
Yeah.
You're
And
very
so
wrong.
basically when their
They
atomic
also have the
number,
same
Their
amount
atomic
of
number.
because
Mhm.
so for the chemical,
outer. They have the same amount of valence electrons.
Yes, that's the answer.
yeah,
Yeah. Same.
In a family, the valence electrons are same. Atomic number is a big difference. So Avni was saying they have similar atomic number. No. There's a big jump in the atomic number. Hydrogen is 1, lithium is 3, sodium is 11, potassium is 19. They are not same at
Yeah.
all. What is same? The valence
the
electrons.
Electrons.
So that's why they have nearly same chemical and physical property. So please read about this and bring your difficulties in the next class. Periods. Do you think in the period elements have the same physical and chemical properties? Similar? No.
In periods, no.
So what is happening to their nature as you move from left to right? They are going
They are
It's changing.
decreasing.
from
They're
metal to
decreasing from metal to non-metal.
metal to non-metal. Yes. So on the left side they are more metallic. On the right side they are less metallic. You remember we discussed that? Okay.
Yeah.
So please read this. Okay. Now they are talking about solids in the periodic table. Did I tell you about solids in the periodic table?
Sorry.
No,
No?
If you did, you would probably brief or something.
Okay. So let's
I don't
come to
think
the
she
periodic.
ever talked about it.
I don't actually think.
Okay, let's see. Now let's talk about the state of these elements. It's a very important question. Hydrogen. I'm highlighting them with a highlighter. Hydrogen, oxygen, fluorine, chlorine, and this complete family.
Should we do that too?
Yeah, these are gases. Yeah, you have extra periodic table?
I can print one out because I already highlighted a lot of them, so it'll be confusing.
mine
if
is
I
like
highlight them
so
again.
filled. I
But
can't
I
even.
already highlighted it, so I
I
can't
told you
really
to have
highlight it
3,
again.
4 printouts, right? You
Yeah,
should
I have
be
a couple of them, but most of them are like colored. So I have to get some that's without color, and then
color,
I can
black and white.
highlight it.
Yeah,
But
I can print one
print
out.
out
I'll
these
just take
so
it
I
You
can
circle
highlight
it. Circle it.
in
Circle
here.
it like this.
Okay, I guess I
Okay.
can highlight it.
Can I
in a
like write
very
down
dark
hydrogen,
color.
oxygen, fluorine, and
Yeah,
then
as
do it later?
gases. Yeah. But hydrogen, do you know the formula of hydrogen gas, children?
Hydrogen?
Yeah, it's H2.
Yeah, I can just
It's H2.
highlight it. Yeah.
Hydrogen gas is H2, right?
H2 and oxygen gas?
Yeah. O2.
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 Fluorine gas
F
F2.
F2.
and
Yeah.
chlorine gas?
Cl2.
Cl2.
So H2, O2, F2, and Cl2. But these are the monoatomic, right? The rest are helium, neon, argon, krypton, xenon, radon, Og. These are monoatomic gases. So these are the only gases in the periodic table. Now let's talk about liquids. Liquids of the periodic table. The liquids of the periodic table are Br2 and mercury. Mercury you have seen in the thermometers. Mercury is a liquid.
I haven't.
And Br2 is a liquid. At what temperature? At what temperature?
Is it room temperature?
Yeah, 25 degrees.
Bromine and Hg.
But there are other metals which also melts around 26, 27, 30. So they have very low melting point. So I'm not going to talk about them. Right now we are just talking about at 25 degrees Celsius. Rest all are solids. Rest all. These are gases. These are liquids. Rest all solids. At room temperature. Rest all are solids at room temperature. You are good with this?
Yeah, 1 sec. Yeah.
No questions? Now we are coming back on the list of the elements. You already know metals and non-metals and metallites. So I'm leaving this part that you please read it on your own. But there are some metals which with very low melting point. Maybe they will be asking to know that also, but I don't think. What are semi-metals?
Semi-metals, they
Metalloids?
have properties
Metalloids?
of metals and non-metals. So that
Yeah.
means
They're metalloids
metalloids.
because
Because
metalloids
they have
are like
both.
metals
Oh,
and
they're boron,
non-metals.
silicon, arsenic, and
they are
And
close.
some of them are like boron, silicon, arsenic, and germanium.
They are on that zigzag line, right?
germanium.
You know, you make the line like this, starting
The
from bottom.
staircase, yeah.
Yeah. So
It's like a little
elements which are around this. So boron.
Oh.
Aluminum is metal. Then this is silicon. This is, I think, germanium, something like that. So the
Wait.
elements which are.
Yeah.
So memorize these names because they may ask you, and they may ask you the reason also. Okay. Alkali metals. Alkali metals are the first group. You know the names? Are they biggest atoms or smallest atoms of the period?
They're the biggest.
Aren't those
Biggest.
the wait? Which ones?
They're the
are
biggest
Oh,
because
they're
across
the
the period, the size decreases, and in so this group would
they're
be the
very
biggest, and on
active
top of that, the very I don't know the lowest one, but the very lowest element in this in the
Cesium.
alkali metals,
They're at
cesium. It's the biggest. I think it's the biggest in element in all of them.
Leaving the
Because
francium.
that entire
We don't talk about this seventh, right? Otherwise, francium is the biggest. But francium is radioactive, right?
So then
Okay. Now answer my question. Kyra answered this question that in the periodic table, alkali metals are the biggest atoms of every period. Right? My question is, now, are they with the highest ionization energy or the lowest ionization energy?
The lowest, because
the lowest, yeah.
they can.
And that's why they are very reactive metals, because they can lose electron easily.
Yeah, can only.
They are the biggest.
Yeah,
So they
they're,
lose electrons
they're very
easily.
reactive.
So they have the highest electronegativity or lowest electronegativity? Avni, you are trying to answer.
Lowest.
Lowest. Because they
Oh,
are
should I
biggest.
be answering?
Aditi answered it already. Avni was just trying to answer, but Aditi answered. Okay, fine, no problem. So can I say alkali metals are biggest atoms of the period, respective periods? They have the lowest ionization energy, so, and they have the lowest electronegativity also, right? And they are the most reactive metals because they can lose electron easily. So that's why they are writing they react with water, they react with oxygen, and they have only one electron in the outermost shell. So please read it.
I have a question.
Mm-hmm.
It says, it says quick fact. It says even though hydrogen is at the top of group one, it's not considered an alkyl metal.
Mm-hmm. Why?
Like yeah, why?
Okay, that's a good question because you know hydrogen electron configuration, children? 1s1?
H2O. Or wait.
1s1, right?
It's 1s1.
Yeah, one is one.
And who is next to it?
1s.
Helium. Helium is 1s2.
Helium.
Helium.
1s2.
1s2.
So hydrogen
And
has
that's
two options. Two options.
yeah.
It can lose one
I just
electron, can become H plus when there is no electron. Or it can gain one electron and it can become H minus. When it is H minus, it is 1s2. When it is H plus, there is no electron. So it has two options. If it is losing one, then it's alkali metal. If it is gaining one, then it is just like halogens. Losing metal, gaining non-metal. That is the reason hydrogen is unique. Yes, Avni, your question?
yeah. No, this is just a correction. Earlier you said that only hydrogen, sorry, H2, O2, F2, and Cl2 are, and noble gases are the gases, but there's also N2.
Oh, how did
What?
you forget about it?
And
Yeah, N2.
yeah, there's N2.
Oh yeah,
Oh, please,
nitrogen.
please write down. Thank you very much,
Nitrogen.
Avni. Thanks.
Nitrogen, yay.
Nitrogen is around us, 75%. Atmosphere is
Yeah.
nitrogen. Thank you very much. N2 is colorful
What
or
about
colorless,
you?
Avni?
It's very colorful. Wait,
Hmm.
no, it's not. It's colorless. It's colorless. I was talking about neon. I was talking about
No, no,
neon.
no, no. You're talking about N2. Okay. So Avni was saying it's colorless. Why she? How can she know the color? How did
Because
her?
it's all around us. It's all around us.
Yeah, and the air around us is colorless or colored?
It's
Colorless.
colorless. It's like it's really
Colorless.
transparent. You can't even
That's what we
see
can see it.
bit
Yeah.
of it.
No, what is the color
It's
of
like
O2
a
gas? O2 gas.
There's no
it's
color.
transparent. No color.
H2
There's no color to it.
It's transparent.
No color.
colorless. Yeah.
There's
H2
color.
Colorless.
H2 H2
H2.
H2 colorless.
colorless. Yeah.
Yeah, it's
CO2
Yeah.
colorless.
gas. CO2 gas.
CO2
Colorless.
colorless.
Yeah,
Colorless.
because it's there in the
Any gas
atmosphere.
is colorless, I'm pretty
No,
sure.
no, dear.
Most?
F2 and Cl2, they are colored.
Well,
Noble
most.
gases, yeah, noble gases are colored. The gases in the air, the gases in the air are colorless because air is colorless.
Yeah.
Nitrogen gas, oxygen gas, carbon dioxide, and even water vapors, water, H2O gas, colorless, is there in the air. Moisture, right? So these can be simple question, but they can be asked there. Sodium metal. So as you go from sodium to cesium,
I just had a question.
mhm,
It's not exactly that much related, but when you pointed out water, basically for water, it's H2O, right? So basically, what if I wanted to have two water molecules? Would that be like it would be two H2O, but could I write it as like four uh
4 hydrogen and
H
2 oxygen.
yeah.
No. That formula is H2O, right? So if you want to say 2 molecules of water, then it is 2H2O.
Okay.
Then it is not 4 hydrogen or 2
Well,
oxygen.
but just saying, but like, no, just asking, would it still, if I still put 4 hydrogen and 2 oxygen together, let's say, would it still become water?
Yeah, 2 water.
Okay.
But you are not going to put 4 hydrogen or 2 oxygens because there is no hydrogen. What is there? H2. So you're going to take 2 molecules of H2 and 1 molecule of O2, which will give you 2 molecules of water. You have done the balancing of equations.
Yeah,
Yeah.
we did it a
Yeah.
while back.
Yeah.
It's okay. We'll
Longer
review
than-
everything. We'll revisit every topic. Okay. Yes, Kyra.
Will you be sending like the quizzes from like the
Oh yeah,
previous
I was gonna ask them. Yeah.
Yeah.
Because like
there's
They're
some
not
it says
gonna
no
see
question
if you
added.
but there's no
forget something.
questions added.
Yeah, it says no questions are added yet.
Yeah.
In which?
Like
In periodic table?
Like
and
at least for
basically
like
all of them.
There's
7 or
so
10
I
or
think in the
so.
previous section.
In like
Wait,
chemical reactions and
Here, I can
wait,
check real
I
quick.
yeah.
I can
So there's
I'll
some
check.
in the fourth there's some in the there's some in the fourth section and there's some in the sixth section. It's valence electrons and Lewis dot symbol in the sixth, and in the fourth it's electron configuration.
I didn't add the questions.
It says
You didn't.
that you didn't add it law of
It
conservation.
says no questions have been added yet.
Yeah.
It says no questions have
I
been
made
added
the
yet.
quiz. Maybe I have not added there. Okay, I made the questions. I remember. Okay, fine. So I'll add them.
Electron
Okay.
configuration.
You can always remind me. Okay, there's no harm in reminding me. So don't feel bad that, oh, we are asking her to do work. If I'm forgetting, then remind me. Because if questions are not there, learning will be not so good. To get an effective learning, we have to practice questions. You see, I'm also giving you so many questions in the class. But after doing with me in the class, if you do it on the website, that will be the better way of learning. So please remind me in case you feel that I'm not placing the questions. I was very busy from last 1 or 2 weeks, coming, going, and hospital trip, but now I'm okay. I'm stable. I'm back home and I can start doing work seriously. So I'll see you then in the next class and we'll discuss from here.
All right.
Right?
Okay.
Thank
Bye.
you.
Bye-bye.
Bye.
Thank you.
Bye. Bye-bye.
Bye.
Bye-bye.